let's continue from what we were doing in the last video and try to find the surface area and volume of a sphere. So let me remind you that the surface area is the same thing as integrating the function 1 over the area, and the volume is the same thing as integrating 1 across the entire sphere. So let's first split up this sphere into many different smaller areas and volumes. So let's look at it this way. This sphere can be split up into a sort of disk in the center, plus a disk up here, plus another disk right here, and so on. So we can sort of imagine that the surface area of this sphere would be the same as summing up the surface area of these little rings, and that the volume of this sphere will be the same as summing up the volume of these disks. So let's first start with the surface area. Let's examine a disk closely. Suppose we're looking at some disk like this. This is the y-axis, this is the x-axis, and it's above the origin. And now let's indicate that we're talking about this disk by giving it an angle of theta. So now, what is the area of this disk? Well, it's going to be the circumference times this little length right here, and we'll call this ds. So what is the circumference? Well, it's simply 2 pi times r, which is the radius. So I forgot to indicate this, but the sphere has a radius of big R. So that would mean that this distance right here, that's going to be big R like this. So the circumference is simply going to be 2 pi times the radius of this little disk right here. And that's not going to be big R. That's going to be r times the cosine of this angle. So it's going to be r cosine theta. Now what is ds? Well, ds is just an arc length, and if you remember the arc length formula for a circle, we have the arc length is equal to r times whatever angle is corresponding to that arc length. And the angle here, we can just call a tiny change in theta. So this angle, we'll call it d theta. So then ds is simply equal to r times d theta. So then let's find the surface area. Surface area is equal to 1 times dA, and dA is going to be the circumference times ds. So the circumference is going to be 2 pi times the radius, r cosine theta, and ds is going to be r d theta. And now we're going to be in the theta world. So we need to find the bounds of integration. Well, as you see, we want to sum up every single strip here, and each one of these strips has a corresponding angle to it. So we want to start from the bottom and go all the way up to the top. Since we're measuring from the x-axis like this, the angle of the bottom one is going to be a right angle, and it's going to be negative. And this angle is going to be positive. So then the bottom angle is simply going to be negative pi over 2, and the top is going to be pi over 2. So now all that's left to do is just integrate this. We can factor out 2 pi r squared, and we're left with the integral of cosine. And as we all know, that's just sine theta. Evaluating this, we'll get sine of pi over 2 is just 1, minus sine of negative pi over 2 is negative 1. So this will give us a 2. So the overall surface area is 4 pi r squared. Similarly, we can do the same thing for volume. Now we also want to find the volume of one of these disks. But here's an important distinction, a slight subtlety. As we take the limit, the volume of this disk is not going to be the area times ds, because this disk is approximately going to turn into a cylinder like this. So the volume of the cylinder is actually going to be the height times the area. And the height is not necessarily the same length as ds. We want to find this value right here. Now let's zoom in big. This is ds. And here we have the horizontal line like this. We know that this angle right here, this is theta, and we know this is theta. Since this is the tangent line of the sphere, there must be a right angle here. So that tells us that this angle right here is 90 minus theta, and if we project this down, this angle right here, assuming this is a straight line, this is going to be theta. So that means this height right here, since this is also a right angle, this height must be ds times cosine theta. So then the volume element, dV, is going to be this area right here, which is simply just the area of a circle with a radius of r cosine theta. So it's going to be pi times r cosine theta squared times this little height, which is ds cosine theta. So that means we have cosine theta, and ds is r d theta, like this. So our volume is just then going to be the integral of dV, which if we simplify everything is now going to be pi times r cubed cosine theta cubed d theta. And of course we want to integrate from negative pi over 2 to pi over 2. So let's do this integral. Let's pull out the constants. Now we have the integral of cosine theta. Well, we can write that as cosine theta times cosine squared theta, which is simply just 1 minus sine squared d theta. Now we can distribute this, and we'll get pi r cubed times the integral of cosine theta d theta, and then we have minus pi r cubed cosine theta sine squared theta. let's do this real quick. Here we have pi r cubed of sine theta pi over 2 to negative pi over 2. That's going to be 1 minus negative 1. We did this already. And then we're going to have minus pi r cubed. And now let's do a quick u substitution. Here let's set sine theta equal to u. So then du is going to be cosine theta d theta. So then in our integral, we'll simply have this is the same as du and u squared. So we'll have u squared du. And what do the bounds change to? Well, when theta is negative pi over 2, we know sine theta is negative 1. So then this lower bound will be negative 1, and the upper bound will just be sine of pi over 2, which is 1. So if we simplify this real quick, here we'll have a 2 pi r cubed minus pi r cubed, and we'll have u cubed over 3 from 1 to negative 1. Now all we need to do is simplify. So that tells us that this is the same as 6 over 3 pi r cubed minus, this is a 2, so we have 2 over 3 pi r cubed. And that gives us 4/3 pi r cubed.